Okay, so for problem set 14, number 32, it says use summation notation to write the sum, then find the sum. And we're given a couple of examples. I'm not going to do the one that's in the problem set, but I'll do a couple that are similar. So a couple of things. First of all is that the sum from I equals 1 to n of a1 times r to the I minus 1 is equal to a1 times 1 minus r to the n over 1 minus r. So again, what we have here is a geometric sequence whose first term is a1 with a common ratio of r. That means we're multiplying whatever this first term is by something, and then we're multiplying it by something again, by something again, by something again, which is why we get this whole exponential term right here. So as we look at this, we need to figure out what is our first term and what are we multiplying it by. So it's pretty clear to see that our a1 here is 4. This is our first term. And if I look at this next few terms and I say, what are we multiplying 4 by? I think you'll see that 20 is 4 times 5. So I'm going to go ahead and write 20 as 4 times 5 to the first power. 100 is actually that times 5, so it's 4 times 5 to the second power, which means I could actually come back here and write that first term is 4 times 5 to the 0 power, plus, and then it continues on. So I need to figure out 4 times what? So I'm going to do it down here. 4 times 5 to what power gives me 12,500? Well, this is an exponential equation, so we go ahead and we divide first by 4, and that's going to give me 3,125. And then to evaluate that, we can take the ln of both sides. So I've got, bring that power down, I've x times the ln of 5 equals the ln of 3125, which means x is going to be the ln of 3125 divided by the ln of 5. We can now go to our calculators and calculate that out. So the ln of 3125 divided by, I didn't need that first set of parentheses there, ln of 5 comes out to be 5. So we get 5. So coming back up here, this is going to be 4 times 5 to the 5th power. So to write it as a summation, we start with I is equal to 1. We'll come back to figure out what that upper value is there. Our first term is 4 times 5. Now, again, what's my exponent? I can't force it. But notice, I'm looking to try to get it to be an I minus 1. Well, if I starts with 1, 1 minus 1 is 0. So that actually is perfect for what we need. And then come up at the other end. What take away 1 is 5? Well, it would be 6. And so I get the summation from I equals 1 to 6 of 4 times 5 to the I minus 1. So now I can use our formula. A1 is 4. 1 minus 5 to the 6th power over 1 minus 5. Now we can go back to our calculator. I have 4 parentheses. Now what I'm going to do here is I'm going to put the entire numerator in parentheses or the entire denominator. Some of you use the fraction, and that's fine. I'll go ahead and do that now since I've got it. So I'm going to go 1 minus 5 to the 6th power over 1 minus 5. It's not bad to come out here and close that just to get used to it. So we get 15,624. So 15,624 is our answer. Okay. And this is something that wouldn't be all that hard for you to just find out what these in-between terms are and go ahead and add them up and check it. But you do. You get 15,624. Let's try this other one. So again, I'm looking at this. This is 2 times 3. Sure enough, that's 2 times 9, which is 3 squared. This is 2 times 3 to the 0. So this is going to be, actually, I need to put the dots in here, the ellipses. 2 times 3 to what? So again, I come down here. 2 times 3 to what power gives me 13,122. Divide both sides by 2. I get 6,000. Let's see here. I don't have it written down. So 6,561. And so I'm going to take the ln of both sides and bring the x down. So x will be the ln of 6561 divided by the ln of 3. So we'll go to our calculators. So I've got the ln of 6561 divided by the ln of 3, and that's 8. So we have up here that this is 2 times 3 to the 8. So we are all set to write this in summation notation from I equals 1. Well, again, we know this top has to be just one more than that. So this is our 9. First term is 2 times 3 to the I minus 1. And again, 9 minus 1 is 8. That's why up here needs to be 9. First term, 1 minus 3 to that n power over 1 minus 3. We can go to our calculator. And we're 2 parentheses, alpha y equals to create our fraction. And I've got 1 minus 3 to the 9th power over 1 minus 3. So 19,682. 19,682. So again, there's our summation notation to write the sum, and then we found the sum. So hopefully that's some help for you on problem number 32.